We are live now.
Yeah. Good evening, all. Good evening, Srinath.
ADITYA-L1 mission will further establish India as a leading space nation. To celebrate India's space glory and to enable students to learn from the experts, Navars Edutech is conducting this masterclass on the Indian solar mission. In this masterclass, you will hear about the mission from the Director of ISRO's Capacity Building and Public Outreach, Dr. Sudhir Kumar in. The Director of R&D at Skyroot Aerospace, Mr. CVS Kiran will also join you to give an insightful session. Hold your breath. The session is about to start. Fresh from the astounding success of the Chandrayaan-3 mission, ISRO is now to celebrate India's space glory and to enable students to learn from the fresh from the astounding success of the Chandrayaan-3 mission, ISRO is now ready to take on an even bigger challenge. Yes, you heard it right. ISRO is all geared up to launch an orbiter mission to the Sun. ADITYA-L1 mission will further establish India as a leading space nation. To celebrate India's space glory and to enable students to learn from the experts, Navars Edutech is conducting this masterclass on the Indian solar mission. In this masterclass, you will hear about the mission from the Director of ISRO's Capacity Building and Public Outreach, Dr. Sudhir Kumar in. The Director of R&D at Skyroot Aerospace, Mr. CVS Kiran will also join you to give an insightful session. Hold your breath. The session is about to start. Fresh from the astounding success of the Chandrayaan-3 mission, ISRO is now ready to take on an even bigger challenge. Yes, you heard it right. ISRO is all geared up to launch an orbiter mission to the Sun. ADITYA-L1 mission will further establish India as a leading space nation. To celebrate India's space glory and to enable students to learn from the experts, Navars Edutech is conducting this masterclass on the Indian solar mission. In this masterclass, you will hear about the mission from the Director of ISRO's Capacity Building and Public Outreach, Dr. Sudhir Kumar in. The Director of R&D at Skyroot Aerospace, Mr. CVS Kiran will also join you to give an insightful session. Hold your breath. The session is about to start. Fresh from the astounding success of the Chandrayaan-3 mission, ISRO is now ready to take on an even bigger challenge. Yes, you heard it right. ISRO is all geared up to launch an orbiter mission to the Sun. ADITYA-L1 mission will further establish India as a leading space nation. To celebrate India's space glory and to enable students to learn from the experts, Navars Edutech is conducting this masterclass on the Indian solar mission. In this masterclass, you will hear about the mission from the Director of ISRO's Capacity Building and Public Outreach, Dr. Sudhir Kumar N. The Director of R&D at Skyroot Aerospace, Mr. CVS Kiran will also join you to give an insightful session. Hold your breath. The session is about to start. Fresh from the astounding success of the Chandrayaan-3 mission, ISRO is now ready to take on an even bigger challenge. Yes, you heard it right. ISRO is all geared up to launch an orbiter mission to the Sun. ADITYA-L1 mission will further establish India as a leading space nation. To celebrate India's space glory and to enable students to learn from the experts, Navars Edutech is conducting this masterclass on the Indian solar mission. In this masterclass, you will hear about the mission from the Director of ISRO's Capacity Building and Public Outreach, Dr. Sudhir Kumar N. The Director of R&D at Skyroot Aerospace, Mr. CVS Kiran will also join you to give an insightful session. Hold your breath. The session is about to start. Fresh from the astounding success of the Chandrayaan-3 mission, ISRO is now ready to take on an even bigger challenge. Yes, you heard it right. ISRO is all geared up to launch an orbiter mission to the Sun. ADITYA-L1 mission will further establish India as a leading space nation. To celebrate India's space glory and to enable students to learn from the experts, Navars Edutech is conducting this masterclass on the Indian solar mission. In this masterclass, you will hear about the mission from the Director of ISRO's Capacity Building and Public Outreach, Dr. Sudhir Kumar N. The Director of R&D at Skyroot Aerospace, Mr. CVS Kiran will also join you to give an insightful session. Hold your breath. The session is about to start. Fresh from the astounding success of the Chandrayaan-3 mission, ISRO is now ready to take on an even bigger challenge. Yes, you heard it right. ISRO is all geared up to launch an orbiter mission to the Sun. ADITYA-L1 mission will further establish India as a leading space nation. To celebrate India's space glory and to enable students to learn from the experts, Navars Edutech is conducting this masterclass on the Indian solar mission. In this masterclass, you will hear about the mission from the Director of ISRO's Capacity Building and Public Outreach, Dr. Sudhir Kumar N. The Director of R&D at Skyroot Aerospace, Mr. CVS Kiran will also join you to give an insightful session. Hold your breath. The session is about to start. Fresh from the astounding success of the Chandrayaan-3 mission, ISRO is now ready to take on an even bigger challenge. Yes, you heard it right. ISRO is all geared up to launch an orbiter mission to the Sun. ADITYA-L1 mission will further establish India as a leading space nation. To celebrate India's space glory and to enable students to learn from the experts, Navars Edutech is conducting this masterclass on the Indian solar mission. In this masterclass, you will hear about the mission from the Director of ISRO's Capacity Building and Public Outreach, Dr. Sudhir Kumar N. The Director of R&D at Skyroot Aerospace, Mr. CVS Kiran will also join you to give an insightful session. Hold your breath. The session is about to start. Fresh from the astounding success of the Chandrayaan-3 mission, ISRO is now ready to take on an even bigger challenge. Yes, You heard it right. ISRO is all geared up to launch an orbiter mission to the Sun. ADITYA-L1 mission will further establish India as a leading space nation. To celebrate India's space glory and to enable students to learn from the experts, Navars Edutech is conducting this masterclass on the Indian solar mission. In this masterclass, you will hear about the mission from the Director of ISRO's Capacity Building and Public Outreach, Dr. Sudhir Kumar in. The Director of R&D at Skyroot Aerospace, Mr. CVS Kiran will also join you to give an insightful session. Hold your breath. The session is about to start. Fresh from the astounding success of the Chandrayaan-3 mission, ISRO is now ready to take on an even bigger challenge. Yes, you heard it right. ISRO is all geared up to launch an orbiter mission to the Sun. ADITYA-L1 mission will further establish India as a leading space nation. To celebrate India's space glory and to enable students to learn from the experts, Navars Edutech is conducting this masterclass on the Indian solar mission. In this masterclass, you will hear about the mission from the Director of ISRO's Capacity Building and Public Outreach, Dr. Sudhir Kumar in. The Director of R&D at Skyroot Aerospace, Mr. CVS Kiran will also join you to give an insightful session. Hold your breath. The session is about to start. Fresh from the astounding success of the Chandrayaan-3 mission, ISRO is now ready to take on an even bigger challenge. Yes, you heard it right. ISRO is all geared up to launch an orbiter mission to the Sun. ADITYA-L1 mission will further
We are 100 seconds past the launch time. The ground and air strap thrust.
BS2, Palestine
It's like one building is lifting off in the space.
Shah and flight path closely matched.
First aid separated. Hello, everyone. A fantabulous evening to one and all. And thank you for all our student community to be patient and to wait for the moment where our guests are actually joining with us today. Okay. So first of all, congrats to ISRO for the successful launch of ADITYA-L1 mission today in the morning. Okay, so let us give big hands to entire ISRO team. So before we begin, I have a small video to play because all of our team are in Sriharikota right now. It is pleasure for us to share the video that we have captured today during the launch. So let me play that.
Rocket launch is more than just a sight. The roaring sound and the vibrations that we get from the fire is just
First aid separated.
We are 100 seconds past the launch time. The ground lead and air lead start thrusting. Thrust.
BS2, Palestine.
So all of you have seen how electrifying was the environment there, and we experienced, personally. So the atmosphere there at ISRO and the crowd and their support, their cheats of all age groups, it was wonderful to see that atmosphere. And we want this atmosphere to continue in the country and grow to a very, very large extent. Okay, so we are obviously proud of ISRO, and it is an immense pleasure for me to have, for our organization, to have Sudhir Kumar sir here with us. And we have Dr. CVS Kiran sir with us, and along with Srinath sir. So first of all, welcome to all of our guests here. And so yeah, we'll give a little bit of introduction to our guests. Dr. Sudhir Kumar sir is currently serving as Director at Capacity Building Public Outreach within ISRO headquarters in Bangalore. He has been with the organization for over 20 years before his career as positions as Associate Director and Senior Technical Project Manager within ISRO. He demonstrated incredible appetite for Indian space missions. He has been an integral part of many celebrated missions by ISRO. His vast experience and specialized expertise in space programs have earned him a reputation for dedication, proficiency, and exceptional leadership in the field. His track record in successfully navigating the challenges of space program management positions him as a thought leader and authority in this highly specialized discipline. So Dr. Sudhir Kumar sir, warm welcome from Navars team to you.
Thank you. Thank you.
Sir, can you please inspire our students? Can you please motivate our students towards this field? And I have one special question, sir, from our team. So our team is wondering, wherever we read about the ADITYA-L1 mission, nowhere it is mentioned. Basically, how much long the duration of the mission is not mentioned anywhere. So is there any reason, sir? Basically, is there any reason behind this? Why it is not mentioned, the duration of the mission? Can you please throw some light in this, as well as please inspire our students with your talk?
You see, forget about why it's not mentioned. The question should be how much. Okay. Two
Yes.
aspects of it. Okay. I really do not know. Should have been mentioned. If fatality mentioned is not there, it may be. I should say that it should have been done. Only that much I can say. But this mission, as soon as the satellite is put into the orbit, precise orbit, ultimately next is what is the next step? How long it will take to go? What is the journey, and what is the next step? So next step is another. I should say in 120 to 125 days, the spacecraft will go towards the Lagrangian point 1, because the spacecraft is going to be placed in the halo orbit around the Lagrangian point 1. Okay. So another 120 to 125 days it takes to travel. Maybe first is orbitizing, and subsequently you can go through the different cycles of orbitizing. Then I should say sun orbit, and it will travel to the near to the Lagrangian point 1, and after that it will be placed, the satellite, into the orbit. So that is the duration. Hello.
Yes, sir, you're audible.
Yes, sir, you're audible.
Fine. So after that, okay, fine. As soon as the satellite is placed into the orbit, it will do a lot of, let us say, in situ measurements and in situ works as per the definite objectives as envisaged in the say project. There's a different instruments are there. 7 instruments are there. VLC, PAPA, FX, such kind of things. There's lots of studies, maybe about the moon, about the sun, coronal effects, how the temperature variation is there from the core to the surface, and how these solar flares are getting generated out of sun, and how these magnetic particles are high energy source particles are traveling, how these how long it will take from these particles to move from sun to earth. So preempting such kind of, let's say, coronal mass ejection, so that our space assets will be protected. So lots of activities are planned using this spacecraft. So in another 120 to 125 days, the journey of this spacecraft from the intended parking orbit or whatever, the landed orbit, into the L1 halo orbit it takes. And from there, maybe 5 to 6 years, the satellite life would be there. Always we have longer life cycles of all Indian satellites based on the fuel availability and based on the function different instruments. We hope this will continue during the days to come.
Thank you, sir, for your insightful points into the mission. Okay, sir, can you do you have any points for our students community, sir? Because all of our students who are joining right now, they are very much enthusiastic about space exploration and they want to become space scientists in the future. So do you have any word for them?
Before becoming space scientists, I should say that you should develop interest towards science. Okay, space is part of the entire science vertical domain. First, you have to pick up the fundamentals of different science, let us say, domains, be it physics, be it chemistry, be it mathematics, be it geology, be it let us say biology. First is all the students should develop the interest towards learning the science and application of science. And next is science applications. You should believe that different technologies will leverage us and different technologies will help us for improving our own, let us say, style of our lifestyles and our social, let us say, living standards. That you should have a faith. And how these technologies, let us say, You are going to earlier, you wanted to book a railway ticket, you have to go and stand in the queues. You are using a mobile app using that. This is a technology development. Earlier, if you wanted to go and understand some kind of, let us say, some travel, how you do? You have to go and keep on asking the people. If you use GPS, it will tell you where to go and how to land. These are all the technologies. How these technologies will improve your social life, you should understand. I should have a faith and belief. Keep exploring these technologies, how to make your life better tomorrow compared to today. After that, let us say space. If you want to become a space scientist, it's most welcome. Otherwise, also you can become any kind of scientist, but have faith and have trust on the science and science technology and technology applications.
Thank you, sir, for your clear-cut instructions to our students, so they understand what to do to become space scientists now. Okay, thank you, sir, for your time. And now we have our second guest, Dr. CVS Kiran, sir. So let me give a little bit of brief about sir. So Dr. CVS Kiran, sir, serves as the Director of R&D and Strategic Initiatives at Skyroot Aerospace, India's first private rocket agency, you can say. So bringing with him an expansive background in materials science and engineering. In recognition of his exceptional academic contributions, he received the DAAD Award for Outstanding International Students in 2008. Over his career, he has significantly contributed to the fields of functional nanocomposites, electron microscopy, and electrochemical materials, primarily during his tenure at the Karlsruhe Institute of Technology in Germany, before joining Skyroot Aerospace. CVS Kiran sir garnered experience as a scientist at Vikram Sarabhai Space Center until January 2021 and has been a guest scientist at HIU and KIT. So CVS Kiran sir has published over 1,000 scientific papers and holds a patent underscoring his influence and credibility in the field. CVS Kiran sir, thank you for joining with us. Can you please enlighten our student community, encouraging them towards this rocket science? So as you know, if you go like half a decade ago, there was we don't have properly functioning private space industry, right? So yeah, now we have a space policy, private space policy, and it is opening up the space industry, right, to everyone. So how do you motivate our students so that they can they encourage towards this field?
Thank you for the kind invitation, and thank you also for the kind introduction. Just a small correction, I have over 100 publications, not 1,000. 1,000 is a little bit more.
Yeah.
And coming to the point, first of all, at the outset, I would like to congratulate Team ISRO for the excellent, show today. In addition to what we recently are still cherishing, the Chandrayaan, and how it has gone over 100 meters today, as we have received news. So basically, let's probably start with why sun. All of us have read a lot about what ISRO is looking. And when you look at my background image, actually at the back, you see how beautifully the sun is when you look at inside a telescope from the Earth. So studying sun is, one side religious practice where we pray it. On the other side, it's very, very crucial for a variety of reasons. Basically, having a fundamental understanding about the nearest star what we have, understanding the origin and evolution, and where the entire energy of the sun comes from, understanding the processes which take place inside the sun is very critical, so that we get the understanding of the entire energy of the ecosystem. And of course, as Sudhir sir just was also mentioning, we also have a very important task ahead of us, that is understanding the space weather, especially because of the fact that so many new satellites are going to be launched in the coming years, where a lot of satellites are going to be exposed to the solar flares, coronal mass ejections, or be it solar winds, whatever type of solar radiation which comes out. And in addition, we are also going ahead in terms of Gaganyaan mission, where protection to our astronauts in future is also very, very important. Or even when we plan our own space station like it was envisaged before, we would definitely require all the information about how it could impact the human body in a variety of cases. And you know, technologically, it's also important because these solar storms have the tendency to trigger a lot of electrical currents, destroying transformers and power grids. Like way back in 1950s, it happened where a complete blackout happened. And it also disrupts the entire communication. If you also see the way how our radios communicate, we also have some ionization issues when we have our radio. Sometimes we don't hear it in our radio. For those people who hear radio, they understand it. But yeah, in addition to that, the study of climate is going on very, very much interesting throughout the world. All these things, including the astrophysical processes, which are critical, are very important for the understanding of the sun. And as a result of this understanding, we have, just for a basic thing, we have around 7 payloads, as Sudhir sir was also mentioning, and you also might have read in the booklet of the information what was given by ISRO. So there is a significant amount of technology which has been developed as part of this, which is not only going to cater to the strategic sector of space, defense, and atomic energy, but also to the general community. So all these things are driven by the strategic sectors. So thus directly we can say that it has direct implications on studying Earth's weather or anything, but it also has indirect implications on driving the entire technology towards the next future endeavors, whatever we have. And you know, as Praveen, you're also interested in astronomy and stuff like that. All of us know from theory, from books, saying that the sun basically consists of 7 major layers, where entire thing comes from what you call the hydrogen and the helium and the nuclear fusion which takes place. I'm not going to talk about all those things, but just the basic points. The immense amount of energy what is there inside, which produces 15 million degrees of temperature, is very, very critical for us to understand. As if you know carefully, recently in the recent past, we have also seen that a country also has put artificial sun in their laboratory and trying to generate energy out of that, and how it could be used for a variety of purposes, either destructive or productive. So all these things are very, very critical for our understanding of this process. For example, after the corona, we have the radiative zone, which is basically taking thousands of protons completely from the core towards the out, where a lot of energy is keeping on traveling. And it takes a lot of years for this energy in the form of protons to come from the core into the radiative zone. And after that, we have the convective zone, where basically everything churns. So in this, like a typical convection, the cooler sun's material, which is cooler, becomes convective. And as a result of that, the churning action of the plasma takes place. And then it comes in the form of a radiative way towards the surface of the sun. And then, yeah, as you see, a fantastic thing. Yeah. And then we have the protosphere, as you see, as the sun's visible surface, when we look at it, is what we see is the protosphere, which is the coolest part, basically, of around 5,500 degrees centigrade. And above that, we have the chromosphere, which is the reddish glow, what you are now holding in your hand. So the temperatures in the chromosphere go towards 20,000s of degrees centigrade, 20,000 degrees centigrade. And then we have the transition region, which is basically the region where we have the, transition of the chromosphere and the region into the corona, where the temperature extremely rises to the maximum. So no material has survived all these things, but how nature has created it is only God's known process. So it has a few millions of degrees of centigrade in the corona. So in addition to these phenomena, there are a lot of solar flares which happen, coronal mass ejections, and a lot of additional types of solar phenomena which happen. So basically, now if we look at the current state compared to what we have done when we were kids, we were all looking when we were kids at some sort of a physical static. Whenever any experiment is carried out, we were looking at the result of the experiment. But now the tendency, what is coming out, is to study everything in situ. So the solar phenomena are very nice to study from a point of view. Yeah, look at a photograph where the phenomena has already occurred, and then understanding it is very nice process which we have studied, and it has been giving humanity all the knowledge. But simultaneously, what is very interesting is to know what is happening during, for example, a chemical reaction, where you can see in process what is happening and understand and create hypothesis or create a way in which you understand the process and deliver it to the humanity. The same way, the lot of solar phenomena are there, ranging from sunspots, which are these dark spots in the sun's photosphere, typically caused from the magnetic field of the sun. And then we have the solar flares, which are the intense bursts of radiation, which are also emerging out from the magnetic regions. And then we have the coronal mass ejection, CMEs, which are called massive bursts of solar wind. And also solar wind itself is actually a wind which is based out of charged particles. And then we also have something called solar prominences, which we forgot. Solar prominences are basically bright features of gaseous, which are gaseous in nature, which eject out of the sun's surface almost always in a loop, which are there, and they extend out into the corona. So, and we also have coronal holes, which are actually areas of the corona where we have magnetic field which reaches into the space and looping back again onto the surface, which allow these high-speed solar winds to completely escape out of the whole thing. And solar tsunamis are also there, helioseismology, solar granulation. And then comes the beautiful part, which is very, very beautiful to see, and which the humanity always tends to see, the auroras, which are actually direct result of solar phenomena, which are beautiful in nature, but are actually nothing but charged particles from the sun, which when they collide with the magnetosphere, they cause these aurora borealis or the australis. And both of these things are very interesting to understand when you understand the whole background of what is happening at the sun. So we are not, the first ones to do this in the world, but we are not the last ones. We are among the top ones. So there have been numerous attempts studying the sun, and we have also gained significant amount of knowledge understanding this, both from the point of view of what people have done and also what people have published in literature. So 1960s already the orbiting solar observatory was launched, then Skylab, then Solar Max, SOHO, Trace was launched, and then Parker Solar Probe is the recent highlight what all of us have seen, and then the Solar Orbiter from the ESA, which was also launched in 2020. So they studied a variety of phenomena, and in this point where we are now there, the solar phenomena is very important for us to study from the Lagrangian point, because Lagrangian point holds a point where between the two bodies, I don't want to repeat things, but between the two bodies where there is significant less amount of gravitational force of both sun and the earth, which leads to the fact that we use very little amount of propellant, which is necessary for the spacecraft so that it can stay in that hollow orbit. And then it enables us to continuously monitor in situ a process. So if, for example, the scientist who's conducting the experiment wants to monitor a process, then he or she can do that in a perfect way. So these sort of, basic basic oblique experimental oriented research is now going on in a massive scale. If you look at the way in which textbook chapter has been written by ISRO for the world, how to land a rover, how to land our Vikram. It is actually a clear definition of defining how we have to land. So that way, I think it has shown to the world during Chandrayaan-3, and we are really proud of everything, sir. So I think it is a way where the next generation is also getting inspired and motivated to be in the science community, taking core branches of engineering, which is very, very important, and then also transmitting this information by staying in that field and also strengthening the manufacturing sector of the country. So if you look, this is becoming very, very critical as more and more people are tending towards non-core branches of engineering like computer science where artificial intelligence people are thinking is the only thing where it will pay, but core branches of engineering and artificial intelligence is the key, and not only the artificial intelligence. So I think with that note, without astronomy or whatever we are trying to study, pure knowledge of artificial intelligence doesn't help. You can pick up artificial intelligence at every stage of your engineering, core branch of engineering. So I, for example, I'm in the field of materials, and a lot of people whom you're probably trying to interact are in their core branches like mechanical and electronics. All these branches, core branches, in combination with artificial intelligence, would lead to the next generation science and technology. So these are very, very important, and I think it should also be taken care with great care that the parents should teach their children to take the core branches of engineering rather than going for computer science and artificial intelligence just because of salary perspective. So I think with this note, I think I will not take much longer time, and I thank you for giving or inviting me for this event. Praveen?
I think Praveen has a little bit of network issue. I'll take it from here. So thank you, Kiran sir. And it was really exciting and enlightening for the students in the audience on this in this masterclass / webinar out here. I wanted to add a little bit based on Sudhir sir and your input, and we have the audience which are parents, which are students, which are some of the school owners out here who are attending this event. And we at Navars are very excited to be a part of this journey with companies like Skyroot who are expanding the territory and the boundaries and opportunities for the next generation employment to happen with the kids who are in the school today. And if you look at the numbers, it's very it's an amazing number of 15 lakh schools today in India, right? And about 28, 29 crores of students at this stage at the school level in India, which makes India the most exciting place of the youngest population across the world, right? And if you look at what's happening in the global space, space sector is the most promising sector in the next 2 decades, right? Because most of these innovation, whether it comes to communication or tourism or research or even war, would be driven through the space communication and the space analytics around. And we at Navars as
probably I can add saying that, for any country to develop in any of the fields, the 3 major points or 3 major sectors which are very critical, one is the space, one is the defense, and the third one is the atomic energy. These are the core strategic sectors which drive each and every field, be it science or engineering or even commerce, any other field. Everything is driven by these 3 sectors.
Absolutely, absolutely. And I think the important point is like for us at Navars, right? Because we are a very small player, and thanks to Sudhir sir and ISRO's space tutor program, we are one of the space tutors who's trying to help students at the grassroots level get connected with space. Like everybody said, Sudhir sir rightly said, don't dream of becoming a space scientist, right? We don't need too many space scientists, right? But we need a lot of space-related employments, right? Because this country would be probably needing a few 100,000 of engineers coming out across different categories of material science, physics, computer science, design people, and biotech guys. We're going to have chemistry guys. We're going to have a lot of, in fact, when we look at it, we realize that space is the most beautiful application of science. And if
even biology,
right? So if this is what exactly at Navars we try and do it, and we try and help students, schools and teachers and parents understand the importance of space at the early age, so that students can start kind of finding their own way, right? They're like touching the elephant at this point, right? And trying to understand different aspects and build a career around it, right? We would definitely look forward to a lot of audience sitting here, listening to us, to understand how much space is relevant, how much space is important, why we should be working towards this, and what an opportunity that lies ahead for India to become leader in the space sectors in the next 2 decades. If you look at a Morgan Stanley number of talking about $1 trillion economy by 2040, and India even contributing 10-15% of that, would result in a few 100,000 of people needing in the next 2 decades, right? And these are the students who are at school now will become promising engineers by 2030 and 2040 timeframe, right? So we would strongly encourage everybody on this platform to take this opportunity, get associated, and move on and build a career around it.
And probably I can add at this point, we recruit a lot of engineers from various branches of engineering, and the minimum amount of engineers what we recruit are from the field of computer science. So,
exactly.
So
Very
the core
interesting
branches of
point.
engineering is the critical path. Mechanical, materials, metallurgy, chemical, electronics, all these are the aerospace are the major fields which are necessary for the country to grow. So I also send the message across to all the parents: build your kids towards next generation India, new India, what we are looking at, especially in the new space regime. I think Sudhir sir also agrees with that point. We need to build the next generation, in such a way that India of our new India of our dreams, and we should go all ahead for it.
Yeah, thank you. All I can say is thanks for Sudhir sir and you taking out time and kind of helping our students understand that. We have Mr. Srinath Mohan from Velamal Group, and we would see if he has a good coverage to kind of speak a few words. And we're very excited to build a new relationship with the Velamal Group and bring some of our schools, empower some of their schools with our lab and our programs. And over to you, Mr. Srinath, if you're around, and if you're in a little bit of better coverage to speak a few words. I think he is not in a very good coverage. That's he sent a WhatsApp chat on that one. So thank you for attending, and we'll now have a small session which Priyadarshan has worked out for the students to understand a little bit more on this ADITYA-L1 mission. And he's going to run through a small presentation and then take a few questions from the audience as needed. Thank you, Sudhir sir and Kiran sir, for your time. And you're most welcome to attend to Priyadarshan's speech and our presentation, and as based on your schedule. Thank you very much.
Thank you.
Over to you, Priyadarshan.
Yes, sir. Yes. So thank you, Kiran sir. It was a wonderful talk that you have covered everything beautifully regarding all the aspects of the sun and other things. So here before that, I just want to address to the students that today we are going to see a small a presentation on ADITYA-L1, and also we are going to explore about the career opportunities. Okay, right? So we need to go in a right direction, right? How to go, like what is the direction? Like if you are interested in space or else any other sector for that matter. Here we predominantly focus on the space sector and the sectors that are associated with it. So we are going to see that. So I just want to run through a small presentation to give you guys the idea behind the career opportunities. Okay, and before that, let me talk a little bit about why Aditya mission is very, very important. Kiran sir has given a wonderful talk on length and breadth of what is the importance of studying about the sun and other things. So here I'm going to show you a few ideas behind the launch of ADITYA-L1. So the question is, like, this is the India's first solar mission. And the thing is, why do we have to study about the sun? Okay, so in order to understand this, see, if we do it successfully, we will be the third space organization to have a satellite in the L1 halo orbit, right? So now we are going to understand why do we have to study about the sun? Very simple. Okay, so in order to study about, like, in order to understand why do we have to study about the sun, we are going to look at something like the weather prediction on Earth. In the past, we were having, like, we used to use high altitude balloons, let it fly high, and then we'll take pictures of the cloud formation and all this. As the technology progressed, okay, so say for example, this is the image. So this is the image taken by the Kalpana-1 satellite launched by ISRO. Okay, so this was the image. Now we can even take the frames of image and interpolate into the video, where we can clearly see the cloud formation, and we can even track the accumulation of water with so much accuracy, and we can predict. Our prediction rate has reached up to 80 to 90% from 30 to 35%, right? So this is one of the satellite like that we launched. This is the one of the most advanced weather satellite that ISRO has launched. So INSAT basically stands for Indian Satellite System, right? Yes, but my question is, why predicting the weather is important when it comes to Earth? That is the idea, right? We should know why we have to predict the Earth. What is the importance behind it? The importance is that, say for example, it is helpful to the farmers who are planning to do agriculture. It is also useful for the fishermen who are venturing into the sea. If the weather is rough, it might lead to loss of life, right? And also when they are planning for any urban events like talk shows, concerts, again, for all these purposes, we will be actually, we are actually dependent on the forecast from these satellites. We should know the weather, beforehand to plan all these events, right? Just like how the weather prediction is important on Earth, the weather prediction is very much important when it comes to space also, because even though we say that there is no atmosphere in space, but there is a different kind of weather that is there in space. Yes. So that is what we call it as space weather. Okay. What is space weather? There is no atmosphere. Then what basically constitutes or else adds up to the concept of space weather? It's very simple. Sun is burning, right? It is constantly emitting, the heat and light. It's the source of heat and light. And in that, it emits some harmful radiations. Okay. So, but we are actually safe because we have a magnetic field around the Earth as a first layer of defense, and then we have a second layer of defense, that is our ozone layer that protects us from UV and atmosphere to some extent, right? But when we are sending satellites to space, now we started venturing towards moon. Soon we'll be venturing towards Mars, Venus, as mentioned by Somnath sir. After the success of Chandrayaan-3, we have planned so many interplanetary missions. So in those cases, this space importance of space weather is very, very paramount, because it impacts our components. Even though we humans are safe, but our electronics, okay, the technological parts, which are not actually safe if you talk about it, because these space weather, I mean, there are certain phenomena in space weather called as solar wind, coronal mass ejection, and solar flares. These can very much impact the functioning of the satellites that are in orbit, the functioning of the communication systems on Earth. Okay, basically these are like fastly traveling stream of charged particles. They can easily fry a circuit. It can in case of a huge, like Kiran sir mentioned, he talked about the black hole that happened due to one of the CME that happened in the 90s. Okay, so we have to be better prepared when we are venturing about space. So just like how we constantly monitor the weather on Earth, we should also have a constant observatory that is always focusing towards the sun, to understand when the solar flare will come. Solar flare is basically like a surface explosion that fires out stream of particles, right? And also there is something called a CME. CME means coronal mass ejection, which means a small portion of a corona, the magnetic field, it gets thrown out. Okay, it is an expulsion. It gets thrown out, and when it travels, whatever the planet that is in the path, it will get affected. The satellites that is around the orbit, or else the satellite that is in the line of sight of this coronal mass ejection or solar flare will get affected very much. Okay, and we do not want to lose $1 million satellites, right? So that is the reason. So what are the advantages of knowing the space weather? Well, there are so many advantages. Okay, the one such advantage is that the predicting space weather, but there is another reason to it. Let's get into that. Before that, let's see something called as our own mission, ADITYA-L1. What are the instruments that are there in ADITYA-L1? Just a small brief. Okay, these are the instruments that are there in the ADITYA-L1. So let me give you, few ideas behind what these instruments do. Very simple. We have an instrument called SUD. Okay, so it's basically a telescope that captures the image of the sun in the ultraviolet spectrum. And then we have, VLC. Well, this captures the coronagraph. Okay, basically, its coronagraph is a solar disk image that basically captures the, amount of activity that happens in the corona. And then we have, Aditya solar wind particle experiment. It's basically, studies the ions that are traveling, the particles that are coming from the sun. And then we have plasma analyzer package for Aditya. Papa, yes. So this also studies about the plasma. Plasma means the charged particles coming out from the sun. And these two, instruments, they basically study about the energy expulsion, the amount of energy that is expelled during the solar flares, quite specifically. And then we have magnetometer. So this is even more important. Magnetometer helps us study about the changes that happen in the Earth's magnetic field when it is hit by a solar flare or else, CM. Okay, that is very, very important. And also it studies about the magnetic field on the sun's surface and also around the sun. But here's the question. However, can we solely rely on the instruments alone? No, right? Basically, we need to keep the Aditya in a specific area called as L1 or else Lagrangian point. This is an orbit, or as in this is a point. What is that L1 or Lagrangian point? See, basically, this is the point L1, which means in simple sense, there is a the gravitational influence of the sun, and Earth also has a gravitational influence. But L1 is a point where the gravitational influence of the sun and Earth balances out. In simple terms, I'm explaining, okay? Which means we would require less fuel, we would require less energy to keep a satellite in this area. And also one of the reasons is that Aditya will always be facing the sun because we need to constantly monitor, right? That is very, very important. So it will always be facing the sun and it will be gathering all the data that are required. Okay. This is the main reason why we have kept it in L1 or Lagrangian point. So there are so many Lagrangian points. In future, we will be using those Lagrangian points. Yeah. But is this the only thing, like, what are we hoping to discover other than monitoring space weather? Well, like Kiran sir has pointed out, sun has a lot of mysteries. One such mystery, one of the most baffling mysteries, that there is something called as coronal heating problem. Okay, coronal heating problem, which means it's very simple. Okay, so imagine this is a campfire. Okay, just imagine sun is like a campfire and the planets are like us. So as we get close to the campfire, we actually, we would actually feel hot as you get closer. But as you get far away from it, the temperature will gradually reduce, right? It will come down. But that's not happening with the sun. The further that you move away from the sun in certain areas, the temperature is actually much higher than the temperature that is there on the surface. This actually contradicts so many of our theories, that how can we move away from the source of heat, but still, the temperature is increasing. So this is one reason. Another reason is the study of how this, helium fusion, hydrogen and helium fusion happens. So a lot of countries are working on something called as fusion reactors. Okay, like we have nuclear fission reactors. Now we are planning to, build fusion reactors, and they have made it. I mean, few countries have made it only for a short span because we still need to understand what is happening at the core of the sun so that we can replicate and make the conditions similar to that core of the sun to, extract as much energy as we can for our energy expenditure, right? So these are the things. There are so many mysteries that are surrounding the sun. And one more thing is that sun is a star, right? Exactly. But studying, there are so many stars in the universe. So studying sun is indirectly studying, so many sun-like main sequence stars in the universe. It's basically studying the sun is indirectly studying about the other stars as well, because their working is more or less the same when they belong to certain categories. Sun belong to a type of category called as G-type category. Sun is a G-type star. Okay, there are like so many category types, and sun is an average size G-type star. So these are all the reasons that we are hoping to find out about the sun through ADITYA-L1 mission. But it's fine. But my question, and a lot of questions from the parents that are coming out, and also from the education institutions, that what are the career opportunities in astronomy and space science, right? Let's take ADITYA-L1 for example. Okay, let's take this mission itself for the example. So these are the payloads that are there in the ADITYA-L1. Payload means the scientific instruments that are used to get the data and observe the sun, right? My question is, who built these payloads that are there in ADITYA-L1? Do you guys have any idea who built these? I'll basically give you one small clue. It's not ISRO. Okay, maybe one instrument that is from one of the bodies of ISRO, but most of the things are not built by ISRO. ISRO took those payloads, made a satellite bus and inserted, and they launched it. Because I'll tell you, there is one more reason also behind it. Before that, let's see who built these. See, these are the bodies and the organizations that have built these components. Say for example, see, what are these bodies? I'll explain. Indian Institute of Astrophysics. People who worked in the Indian Institute of Astrophysics, they built this component called as suit. And then there is IUCAA. We call it IUCA, Inter-University Center for Astronomy and Astrophysics. And then we have URSC, UR Rao Satellite Center. And then we have something called as PRL, Physics Research Laboratory. They built few more components, I mean the payloads. And then we have Space Physics Laboratory. They have built few more payloads. And then we have LEOS. LEOS stands for Laboratory for Electro-Optical System. Okay, so this is, as you can see, it is all built by various space centers all around the India. Okay, and we have URSC who have built this Helios payload, and then we have SPL built this Papa payload. They are based out of Thiruvananthapuram. UR is based out of Bangalore, and then UCA is based out of Pune. There are so many bodies who have built these. But do you know how many such space centers and institutions there are in India? Okay, it's an astounding number actually. Okay, this is basic. If you see, there are around 30 plus space centers. Okay, out of which ISRO has few more space centers. That is basically like ISRO has around 21 space centers. Okay, like you have a human space flight center where they are working on Gaganyaan mission. Okay, so they are planning to put a man in the space by building a space module and all those things. And we have IRRS where there are scientists who are controlling various aspects of the satellites like data acquisition and all those inertial systems, propulsion complex. Like this, there are 21 plus space centers which provides lots and lots of opportunities, career opportunities. Not only this is just ISRO's space centers, right? And there are few more autonomous bodies like Indian Institute of Space Science and Technology and Indian Institute of Astrophysics. And then we have this PRL lab which has built Papa. And then there are so many such autonomous bodies that are building. Okay. There are so many autonomous bodies that are building these components, and there are so many opportunities that are available. And in 2040, space sector is projected to be $1 trillion industry. Okay, so you have to, you can actually foresee the importance of space industry in the coming future. It's going to boom, right? Not only the government bodies, we have so many wonderful space agencies like Skyroot Aerospace. They have recently launched Prarabh. Okay, then we have Agnikul, Dhruva Space, Pixel, Bellatrix, Manastu Space. So there are so many private space agencies that are emerging, that are providing a lot more opportunities to people in the space sector, because they need a lot of talented young minds, minds actually. So how to get into the space agencies and space centers? Yeah, that is the most important question, right? Yes. In order to get into that, you need to crack the exams and interviews, because this field is competitive and it needs someone who's talented, who has the understanding of all the concepts. Like, you need to have an adequate knowledge and proper understanding of physics, chemistry, mathematics, and other scientific fields, as pointed out by Kiran sir. And then they should have exposure to the recent developments. They should be up to date. And there should be an experiential learning through which they can learn so many things by having a hands-on experience. That is even more important. This is what we call it as an experiential learning. But where will you get all these together in a single place? Yes, that is where the idea of Space Lab comes, powered by Navars. Our Space Lab basically inculcates various aspects like this in the students' mind, so that they can understand, they can start from the beginning itself, as their projected growth will be much higher as they travel through the curriculum and the other teachings from the Space Lab. So before that, I just want to show a small video from our Space Lab and how it happens. Yes. Basic, 1 second, I'll just share the sound. Yes.
Exactly. Different gravity and different atmosphere, right? And
behind Space Lab, as you can see, that we focus more on the understanding part, and also we also inculcate various scientific skills that are needed to understand certain concepts and to travel through the multi ladder steps towards space. So this is the idea behind Space Lab. And then once you the schools who's signing up for this, they've given a wonderful feedback about how their learnings have improved, because see, when you want to study about space, you have to have an understanding of physics, chemistry, and mathematics, and various even computer science. So many things. Like when they focused on this specific part, like Space Lab, their interest towards various other subjects have grown, and this is the kind of feedback that we have gotten from multiple schools, and we have so many such labs signed up with so many schools. And next, I'll just show you a small video of the other things. Meanwhile, if you have any questions, you can put up those questions in the live chat box where I can answer. Yeah. Yes. So you can just take a look at this video. Meanwhile, if you have any doubts, you can let me know. Yes. Praveen sir, I think it's if we can open the live chat box, we'll be getting some questions.
Yeah, sure. Yeah, sure.
Yes.
Now it is open. They can ask
Yes.
their questions in the chat box.
Yes. Thank you. So yeah, so the live chat box option is open. Now what you can do is, if you have any question, you can put that forward, and I can answer your questions.
Okay, so I have one question because
Yes.
we were interacting with our students throughout the day
Yes.
today here in
Yeah.
Kota.
Yes.
And most common questions that we are getting is that, like, we had terror time for Chandrayaan-3 landing, isn't it? 20
Yes.
minutes of terror. And
Yeah.
do we have terror time for ADITYA-L1 mission? And this question can be answered by Kiran
Yes.
sir also.
Kiran sir, yes.
Can you hear me?
Yes, sir, we can hear
Yes,
you.
sir.
Hello?
Yes, sir, we can hear you.
Yes, sir, we can
Can
hear
you
you.
repeat the question, please?
Yes.
So the question is that we heard that the 20 minutes of terror for Chandrayaan-3 mission, isn't it? And do we have such kind of a terror time for ADITYA-L1 mission too, where the phase is very, very crucial?
Critical phase is already been through. So there is no landing associated. This landing is one of the most critical points which everyone has to be careful about. So if you pass through the landing, there is no more thing in this. So there is no more critical part in this. Of course, there might be some critics about possibilities where debris, space debris. So that is only one concern which I have in mind. But ISRO already takes care of all the space situational awareness to the greatest possible extent. So the chances are very risky, very less. But recently, for example, if you know there has been this one of the Russian old satellite has imploded, resulting into a lot of debris at around 800 kilometers orbit. So I don't think anything will reach, but yeah, so some concerns like that would exist in the minds of people, but nothing as such.
Okay. Okay, sir. Thank you. Thank you. So we are getting a lot more questions. So what is the point of coronal heating, sir? This can also be once again answered by Kiran sir if possible. Kiran sir, am I audible? Yeah. Okay. So, okay, fine. So, yeah, I think he's having some network difficulty. So, coronal heating issue, if you take, the reason behind the coronal heating issue, still we do not know, because as you see, the surface of the sun is not as hot as the corona, which means the source of heat, the surface of the sun is around 6,000 degrees Celsius. But if you take the temperature of the corona, it is around 1 lakh degrees Celsius. How is it possible? We still do not know. So for that reason, that is the heating problem, because it is contradicting with many of our theories that states that, as you move closer to the source of heat, you will receive lot more heat and there will be more temperature. The temperature will increase. But when you are moving away from the sun, in that coronal region, I mean the area of corona is basically the atmosphere of the sun, if you see. So the temperature is increasing a lot. But in reality, as per our understanding, it should decrease. Okay, yes, that is the idea. Kiran sir, can you hear me? Okay.
Yes, can you hear me?
Yes,
can
sir.
You hear
Yes,
me
sir.
now?
Yes. Now I can hear you, sir. Yes. So yeah, no issues, sir. So there is another question that is related to a simple question. How corona is produced by Gaurav?
How corona is produced, or how coronal heating is actually, corona is actually the outermost layer of the sun, which is actually very, very hot. And it is as a result of this nuclear reaction and the multiple areas or multiple layers of the sun which are existing, that this layer is also a layer which has been defined by our scientific community. So the corona actually, if you ever have seen, through the eclipse glasses, that is during the eclipse, you can actually very well see the corona.
Yes.
The white halo, what you see, the shimmering, that is actually the shimmering white halo. That is actually the corona, what you see. And it is the hottest of the entire outermost surface layer of the sun.
Okay.
How it is produced as a result of multiple amount of nuclear reactions, which are based out of hydrogen and helium inside the sun. And, by the time that reaches to the outermost surface, because of this radiative zone and passing through the radiative zone, it takes actually probably thousands to millions of years. God only knows. No one has ever got information about this. That's what everyone is intrigued about. And, all these answers, although we answer, I expect that we could probably answer them, after the next generation gets more deeper understanding of that.
Yes. Okay, sir.
And in fact, very important point, don't ever try to look at the sun directly. Sun has to be viewed only through proper protective glasses, proper protective telescopes, not the normal telescopes. There are special solar telescopes for that purpose.
Okay. So thank you, sir. There is one more question that is emerging, and so it is from Dia. Sir, will Aditya be disrupted if solar storm hits when it goes near the halo orbit?
So what happens is, normally whenever any of such activities happen, especially in terms of any of solar activities happen, it spreads out normally in such a way that Earth is very rarely affected by this whole activity. On the other hand, if a satellite gets affected, for example, we recently had around 41 satellites, if I remember correctly, were totally affected and got destroyed.
Starlink satellites, right?
From SpaceX. So
yeah,
Starlink satellites. And
yes.
likewise, satellites get disrupted, but a lot of protective protection is given, by ISRO, and I could really be proud and say that the way in which ISRO gives protection or shielding against radiation, it's much better than anyone else in the world because of the fact that we are much more careful about our activities.
Okay.
And the radiative shielding was given inside protects significant extent. All these things.
Okay. Okay, sir. Superb, superb. Thank you, sir. So yeah, there are few general questions that is related to Chandrayaan. Okay, so when the sun will rise after 14 days, will Chandrayaan 3 and the rover be active? So, sir, you have.
So I can probably give a small answer about it.
Yes.
I can actually give you a small answer about it. I
Yes,
really hope it does. Normally, whenever ISRO gives, it is actually the minimum possibility. But after 15 days, if the battery is able to survive that, and if it's able to recharge itself, if the sleep time is able to cover, we really hope that it survives one more day.
Yes. Okay. Okay. Thank you, sir. So yes. Okay. So, and a few more question is that, sir, where will ADITYA-L1 revolve? Between Earth and Venus? They're having this doubt since it is like 1.5 million kilometers. Yes, sir, this is going to be the final question, and then, yeah. Kiran sir, can you hear me? Okay. Okay, I think yes, he's having some network difficulty. So I'll take one more question. Yes. So see, L1 is a specific point. It's not very, like, it is not that it's close to Venus. I think Kiran sir has joined. Yes, let him connect to the audio. Yes, Kiran sir, am I audible?
Yeah, I'm actually going through a region which is not properly with signal, so I'm sorry for the disconnection which is happening frequently.
No issues, sir. No issues, sir. Our students are very enthusiastic to, get insights from.
So what I was saying in the previous question is that the Lagrangian points, there are multiple Lagrangian points which are existent, and L1 is the best one of the Lagrangian point, and then L5 is the next best, is what people have showcased. At this point, basically you have zero effect of the Earth's gravitational force, and you have zero effect of the, or negligible effect, basically negligible effect, not zero, but negligible effect of both the bodies. So that is the way it is made in such a way.
Okay. Oh yes, yes, sir. And there is one more question that is a follow-up this question. So they are asking that since L1 is around 1.5 million kilometers from the Earth, like, is it in between, Venus and Earth? Like, that is their question.
Normally, it is seen that no shadowing effect is observed. So I don't expect any of the shadow of, transit to occur. But if a transit, Venus, when Venus comes in between, it is called a transit. But I don't know how it has been designed in that mission planning, how they have done it.
Okay, 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 sir. Thank you for your wonderful insight, sir. Thank you, Srinath, sir, from Velamal Group of Institutions. Thank you so much for sticking around and seeing our wonderful guests giving insights to the kids. Thank you, Kiran, sir. Thank you, Srinath sir. Thank you so much. Yeah. Bye bye, everyone.
Thank you very much. Thank you all
Thank
for joining.
Yes.
So for all the students who have further queries, they can post in the community. They can go
Yes.
to Navars website and they can post their questions on the community so that the question and answers will keep on going. Okay. So all the best. Keep learning. Keep exploring. Bye bye. Take care.
Thank you. Take care, everyone. Bye bye.
Thank you, Srinath sir. Thank you very much.